All right, folks, these are video solutions to the battery energy worksheet. Bear with me. I left my pen tablet at school, so I'll be writing with my mouse. Okay, so we've got a combat robot single loop circuit. You know, the battery voltage. Oh, the first thing I wanted to say is the connection between formulas on this equation sheet is I. Okay, so you might do the Ohm's law first and then use the battery energy, or you might do the battery energy first and then use Ohm's law. Okay, so there is no physics Sudoku for figuring it out. There's no system of putting things in boxes. But hopefully by now you're feeling pretty good about understanding what you know and what you don't know. Okay, and if it helps to identify everything to get yourself organized, then that's a great place to start. So we got the voltage and we have the battery energy. So that's a hint that we're going to start with this battery energy formula. And you know the ohms of resistance. So you will use that at some point as well. The first thing we want to do is find the current. And again, so the current can be either equation, but since we know battery energy, then battery energy equals I T, and I did capital T to give you a hint that that's in hours. Okay, so we have 1.8 amp hours. You know what? I'm gonna type this. So if you have 1.8 amp hours equals I, which we don't know, times time. Oh, look, we can't solve this. See, even Miss Crappy gets it wrong sometimes. We're like, oh, psych, we don't know time or current, so not a problem. Let's just go and realize we should have done Ohm's law. So we have I equals V over R, and we know the voltage is 12 and the resistance is 4.4, and that gives us 2.73 amps of current. Yay. Okay, so that is A. And then B says how long in time can the robot run before the battery needs to be recharged. So we know, so this is actually question B, we know battery energy is 1.8 amp hours, and that equals I times T. But I, we now know, is 2.73 times T. So we're going to divide both sides by 2.73. So 1.8 amp hours divided by 2.73 amps. So you can see amps are going to cancel and you get 0.659 hours. Okay. Okay, awesome. So that is number one. So we're using both equations, and it just depends on which one you use first. Okay, so now he wants his robot to move faster, so he gets a higher voltage. But I want you to think about this logically, in case there's a logic question. This battery is giving away 20 joules of energy to every coulomb of charge, but it has the same amount of stored energy. So it potentially is going to run down faster. Now it's going to have a different current, but guess what? The current's going to be higher because the voltage is higher. So you're going to have both more current, more electrons per second, and more energy given out per electron. So that's doubly bad if you want to preserve your battery life. Okay, so question A is find the current in the new circuit. So I still equals V over R. So 20 volts over 4.4 ohms is 4.55 amps. Okay, so was 2.73, now it is 4.55. And And now let's see how long that lasts. So length of time is battery energy. So battery energy equals IT, and we have 1.8 amp hours equals the 4.55 amps times the number of hours. So we're going to divide both sides by 4.55, and the time is 1.8 amp hours divided by 4.55 amps. So the amps cancel. That's why hours is an amp hour, not an amp divided by an hour. So the amps cancel, leaving you with 0.396 hours of battery life. And then in my PDF answers, I converted that to minutes just because I don't know what that is. It's, you don't have to if it doesn't tell you to, but it is about 24 minutes. Okay, so moral of the story is we had 0.659 hours, and then now we have only 0.4 hours because, again, the battery's giving away energy, more energy per coulomb of charge that goes by, and there's more coulombs that are going by every second. Okay, number 3. Now, Becca's making a combat robot. She has a 16-volt battery with not very much amp hours of energy, and she's going to a competition that is 16 matches the last 10 minutes each. So question A is, how long does she need her robot to run? And that's just like a logic conversion, not a physics formula. She has 16 matches, and each match is 10 minutes. So it needs to last 2.66666 hours. Oops. I skipped a step. 160 minutes, and then if you look at my PDF answers, I did 160 minutes. I'm going to have to do this with a pen. So delete that. So we have 160 minutes, and there are 60 minutes in an hour. Sorry about the handwriting. And that is 2.6 repeating hours. So a little over 2.5 hours, right? That's how much time, 2.6 repeating. Okay, letter B says, hey, she wants to use as much current as possible because current is bringing energy to her circuit, which, and the more energy, the faster her robot's going to go. So what's the max current she can use in order for the battery to last 2.6 repeating hours? So, why is it doing that? Okay, so this is B. Maximum current and time means we're doing battery energy equals IT, and the battery energy was given as 0.26 amp hours equals the current, which we don't know, times the time, which is 2.6 repeating. Okay, so divide both sides by 2.6 repeating, and I equals 2.6 divided by 2.66666 equals 0.10 amps, a tenth of an amp. Okay, that is the answer to B. And then C says, what's the resistance of the motors that she should use? So now we're using Ohm's law, I equals V over R. And we know the current is 0.1. We know the voltage is 16. And so we're solving for the resistance. This is a little tricky because what we're solving for is in the denominator. So I'm going to get out my pen again. So what we have is 0.10 equals 16 over R. We're going to cross multiply. So 0.10 R equals 16 times 1. And then we're going to divide both sides by 0.10. So 16 divided by 0.10 is 160 ohms. Horseshoe. Okay, so that's the resistor, the amount of resistance she should use. All right, again, apologize for the sloppiness. Okay, last question. Devin, that is my cousin's daughter who's doing engineering, is designing a new smartphone. The phone battery has a voltage of 4.7 volts. If you're watching videos, that takes a lot of energy, and the resistance is 14.5 ohms. She wants people to be able to watch 10 hours of video, so she needs to know how much energy she should make sure her batteries can store. Okay, so we know the time, and that's in hours. That's good. We know the voltage, we know the resistance, but we want battery energy. If you start with the battery energy formula, you will realize I don't have the current and I don't have the time. So again, not a problem. Let's just calculate the current. So come on. So I equals V over R. And you can see we have the diagram up above. So 4.7 volts divided by 14.5 ohms is 0.324 amps. So that is the current in that single loop. And then we want to know how much battery energy we need. So that's the current times the time. And we now have the current is 0.324. And the time that we want is hours. So that's easy math, 3.24 amp hours of energy. Yay. Okay, so that's the work she did. Now she's ready to design and build that battery. Okay, that is A. Well, some days people aren't going to be watching video. They're only texting. So that's not going to use as much energy. So that actually has more resistance. And we want to know how long that will last. So again, clearly, how long is time? So you might jump in and go, oh, I still have the same battery energy, but you don't have the same, which is true, but you don't have the same current, right? This is a different circuit. So you have to find the new current. So let's find the new current. So I equals V over R, which is 4.7 volts over 32 ohms. So the current in this circuit is 0.147 amps. And I hope this makes sense that she designed the battery, right? So it's the same battery. So battery energy equals IT, 3.24 amp hours equals the new current times the new time. So you're going to divide both sides by 0.147, and you get that the time it will last is, 22 hours. All right, so you can have a marathon texting session. All right, those are the answers. Again, the moral of the story is you're using Ohm's law when you're looking at the circuit, and you're using battery energy when you want to see how long that's going to last. All right, thanks for listening, and I'll see you in class.